Let's go ahead and apply what we've learned about solving equations to this practice test for the end of Unit 1. So here we go. On this problem right here, all we need to do is isolate this variable y. So we're going to get rid of that minus 9.7. So we're going to add 9.7 to both sides. So we'll add 9. Whoops, I wrote that backwards. 9.7 to each side. Those are going to cancel each other out. We're going to have a y on this side, and then we have 1.7 plus 9.7. I'm going to bring up the calculator just to compute that answer for us. Just double check and make sure we get it right. So we're going to have 1.75 plus 9.7, and we should have a general idea of what this should be. This is about 10 and that's about 2, so we're looking for an answer somewhere around 12, maybe a little less than 12, and we get 11.45. So I'm going to write down 11.45. We're going to circle that, and there's our answer. Move on to the next one. Notice we've got some distributing here, so we're going to go ahead and distribute through. I'm going to draw those little arcing lines there. So we get negative 3r. Negative 3 times 5 is going to be negative 15. Then we have that 21 over there. We've now got a two-step equation. Here's the variable term. This is what we want to isolate before we get the variable isolated. So we want to get rid of that subtracting 15. So I'm going to add 15 to both sides. I'm just going to move this over to the other side, and that's what happens when we move it over there. So we've got the equal sign right here. 21 plus 15 is 36. We've got the negative 3r right here, and then we're going to go ahead and divide both sides by negative 3. So I'll divide here by negative 3 and there by negative 3. Those are going to cross cancel. That's going to make a 1r, which is what we're after. And we've got a positive divided by a negative, so the answer is going to be a negative. 36 divided by 3 is 12, so our answer on that one is negative 12. So we'll take a look at the next one here. We've got some distributing to do here, so I'm going to go ahead and demonstrate that. So we have a negative 5x on this side, and we've got a positive 45 over here. There's nothing to simplify over on this side, so again I've got the negative 5x and then plus 45 over here. Again, we always want to simplify the sides before we start to solve. That's what we did on number 2. That's what we've done here. And then we've got a variable on both sides here, so let's take a good look at this. We've got a negative 5x over here and a negative 5x over here. We always want to move the smallest one, so the choice here is we're either going to move the negative 5x or the negative 5x. And when you think about it and say it that way, that should ring a bell. If we do that, we're going to get rid of either one of these. We're going to add 5x here and add 5x here. And here's what happens if we do that. This makes a 0, which leaves a 45 on this side. That makes a 0, which leaves a 45 on this side. So we get 45 equals 45, which again should ring a bell. This is a true equation. There's nothing we can do to mess this up. So any number we plug into the original one, and again notice negative 5x plus 45 on this side, negative 5x plus 45, those two sides are going to be the same no matter what. So what we get here is infinitely many solutions. And again, I don't mind if you abbreviate that, but you do need to say it correctly every time. So that one has infinitely many solutions. Tons and tons of answers. Any number you can think of would work there. Let's take a look at this one right here. Both sides are simplified. We do have a variable on each side, so we're going to get rid of that t. But do spend just a second thinking about this. This says t plus 5 is the same as t minus 5. There's no way that could be true, but let's just check and see what happens if we get rid of those t's. We get 5 on this side equals negative 5. This is not a true equation. There's no way 5 equals negative 5. So the answer we get on this one is no solution. So we'll go ahead and write that, and we're all set to go. Let's take a look at the next one. Here's the variable term. We're going to isolate that. I'm going to do that by subtracting 3 on this side and subtracting 3 on this side. So we get a 2d over here. On this side we get a 32. We finished solving this and isolating that variable by getting the d by itself, so we're going to divide both sides by 2. Those are going to cross cancel. 32 divided by 2. 2 does go in there evenly, so we get a nice clean answer of 16 on this one. All right, let's take a look at this one. We do have some simplifying to do, so let's go ahead and distribute through and simplify. So we get a 2, we get negative 4h. Over on this side we have h minus 5. Again, we want to move the smallest variable term. That's going to help us work with fewer negatives. It's going to make the coefficient on that variable a positive. So we're going to do this by adding 4h to this side. Now, those are going to cancel to be a 0, so that means the h's are going to end up over on this side. So if the h's are going to end up over here, let's go ahead and move the -5 to the other side by adding 5 to both sides. So those two are going to cancel. So here's our equal sign right down the middle. We have a 5h on this side. We have a 7 over there. 2 plus 5 is 7. And then we're going to finish this off. We're going to isolate that h by dividing both sides by 5. Of course, those cancel, so we get an h over here. 5 doesn't go in there evenly, so we stop thinking of this as a division problem and start thinking of it as a fraction. The fraction 7/5 does not reduce. We wouldn't want to change that to a mixed number or anything like that. That's a reduced improper fraction. That's a perfectly acceptable way of writing the answer on that one. So we'll take a look at this one here. We need to get rid of multiplying by -5. Again, we're going to divide by -5, so we're going to cancel the two of those. We get an n on this side, and then I'm going to type that into the calculator. We're going to get 48.95, and then we're going to divide that by negative. Remember, the negative's right here. Divide that by -5. Hit enter, and we get -7.79. It's not a continuing decimal. We don't need to round it or anything. Let's go to the nearest hundredth. So we're going to do -9.79. So -9.79. One-step equation right there, so not too bad. We do get a decimal answer, but we can handle that. Let's take a look at this next one. We've got some variables on both sides, both of which happen to be decimals, so it's going to be okay if we write the answer to this one as a decimal. Remember, we always want to move the smallest one, so the smallest one would be this 0.15x. So let's move that before we start figuring out which numbers we're going to move around. So we're going to move this to the other side by subtracting 0.15x. Subtract 0.15x. If we're going to get the variable over on this side, because those two cancel each other, let's move the 92 over to the other side. So let's add 92 here and 92 there. Those cancel each other off. Let's see, 0.35 plus 0.15. Minus 0.15. That's kind of like 35 minus 15. But again, just to double check and make sure we're getting this right, this is preparation for a test, so let's make sure we get this. 0.35 minus 0.15 is going to be 0.2. So this is 0.2x. And then again, those canceled, those canceled. So on the other side, there's that equal sign in the middle. We've got 21 plus 92. And again, if we need to, let's just double check that. 21 plus 92. If you've got a mental idea of what the answer should be, we're probably going to be a little over 100. I think we're going to be 113. Yeah, 113. So we've got 113 on this side. And then we need to get rid of multiplying by 0.2. We're going to do that by dividing by 0.2. And we'll throw that into the calculator to see what we get here. So notice that we've already got the 113 in there. So I'm just going to hit the divide. It's going to recall that answer of 113. We're going to divide by 0.2. Hit enter, and we get 565. So we get x equals 565. So a little bit surprising that we'd have these decimal answers or decimal problem and then get a whole number here, but that works out just fine. You might want to think about why this answer is so big. We've got this number 113, and we're dividing by this pretty small decimal. That small decimal is going to go in there a lot of times. That's why that number gets bigger rather than smaller, which usually happens when we divide. Okay, we're going to flip the page over and take a look at this one. This is number 9. Again, we're going to simplify the sides before we solve. So we're going to simplify over here by distributing. And -8 there. And distribute through, we get 8s and +8 here. Okay, so we'll finish this by looking at this and figuring out which variable we're going to move. I'm going to move the smallest one, so I'm going to move the 4s to the other side by subtracting 4s. And because that's going to leave the variable over on this side, I'm going to move this 8 to the other side. I'm going to do that by subtracting 8 from both sides, because I get rid of adding 8 by subtracting 8. So we end up with a -16 over here, and then on this side, 8s minus 4s is 4s. And then we've just got this one step to finish this off. So we have an s on this side. Negative divided by a positive is negative, and 16 divided by 4, of course, is still 4. And there we go on that one. All right, more simplifying to do here. So let's take a look here. We've got some like terms over there. So let's combine the 19j and the 10j. So this is -19j plus 10j. That's going to be -9j. and then we've got the plus 2. And then over on this side, we've got some distributing to do. So that's going to be negative 9j. And this is going to be plus 3. Don't forget, when we distribute that negative through, it's going to change the sign of each of those. And then plus 1. So here's what we've got. Negative 9j plus 2 on this side equals negative 9j plus. If we combine those like terms right there, we get plus 4. And let's just think about that for a second. This is saying that negative 9j plus 2 is exactly the same thing as negative 9j plus 4. Well, there's no way that can happen. I don't think this is going to have a solution, but let's just double check. Let's add the 9j to both sides. So those are going to cancel. We get 2 equals 4. We know 2 doesn't equal 4, so on this one, we get no solution. All right. Let's take a look at this next one here. We're going to distribute so that we can simplify each side. Notice that we've just got a 1 over here, so that's going to sit over there for the time being until we figure out what we've got here. This is a negative 15, and then we've got plus 7k. That negative 1's right there. So we're going to put the two of these together. These are like terms right here. So this is going to give us a 4k on this side. And let's see here. We've got that minus 15 equals negative 1. Then we're going to move the 15 to the other side by adding 15. So we get 4k equals, this is going to be positive 14. Remember, these have different signs, so we find the difference between the two of those. The difference between 1 and 15 is 14, and the bigger one's positive, so we're going to keep that positive. And then we're going to divide both sides by 4. And again, once we get here, we don't panic and think, oh my gosh, 4 doesn't go into 14. If 4 doesn't go into 14, that doesn't mean we did anything wrong. We're going to stop thinking of this as a division problem, and we're going to start thinking of this as a fraction. We've got a 14 over 4. Those are both even, so 2 goes in here 7 times and 2 goes in here twice. So that means our reduced improper fraction is 7/2. So we'll go ahead and circle that one. All right. Again, some distributing here. So let's see, we've got 4u minus 28. We've got 9u minus 36. I'm going to move the smaller one, so I'm going to move the 4u over to this side. That means we're going to move the 36 over to that side, so we're going to add 36. So this gives us, let's see, we've got a 5u. We like that positive exponent there. When we do negative 28 plus 36, we get a positive 8. Finish this off by dividing by 5. Those cancel. We happen to get a fraction on this one as well, so we're going to write down 8/5 as our answer. Again, we're not going to change that to 1 3/5 or anything. We like those reduced improper fractions rather than changing those to mixed numbers. Mixed numbers just turn into a hassle if we have to use them later on or anything. Okay, let's take a look at this one. We're going to move the 55 to the other side by adding 55. So we get w over 2 equals, I think I can figure that out. I think that's going to be 162, but let's just double check here. Again, we're getting ready for a test, so let's make sure we're getting this right. 107, and then we're going to add 55. We get 162, so this is 162. And then again, we need to get that variable by itself, so we need to undo the dividing by 2. So I'm going to multiply by 2 on this side and multiply by 2 on this side. Those 2's are going to cross cancel. We end up with our w here, and then 2 times 162. We might be able to figure out what that is, but let's just hit times. That's the 162 for the answer there. And then we're going to times by 2, so our answer on this problem is 324. 324. Okay, let's take a look here. We've got 52 plus m. That side is already simplified, but this side is not. We can combine those like terms. We've got 99 minus 47. And again, just to double check, let's not make any mistakes on a test. This has got too much writing on this. We want to really show that we know what we're doing. So 99 minus 47 is 52. So on this side we get m plus 52. So here we have 52 plus m equals m plus 52. You might already have an idea of what the answer is. We do have a variable on both sides. Let's go ahead and get rid of that by subtracting m from both sides. So we get 52 equals 52. And that is a true equation. There's nothing that we can do to mess that up. So on this one, we would have infinitely many solutions. Okay, so we ran into another one of those. All right, last couple problems here. This one's on here. This is always a good one to make sure we're aware of the details here. Remember, this fraction bar, this long fraction bar, we've got two terms on the top here. So those are grouped together. That fraction bar groups those together. So we want to undo the dividing by 7 first. So I'm going to multiply this side by 7 and multiply that side by 7. Those are going to cancel. We're going to have a 4 plus r. We just get that numerator left. And then we've got this 6 times 7. 6 times 7 is 42. We're going to finish this off by subtracting 4 from both sides. We end up with an r on this side, and 42 minus 4 is 38. And we'll circle that, and there's our answer. And we're on the very last one now, and we do have some fractions to deal with here. There's no simplifying that we need to do on either side, but we do have a variable on each side, so we are going to want to figure out which one of these we want to move. We've got 1/8 n and we've got 3/8 n. Well, they've got the same denominator, so that makes it pretty easy to figure out which one's smaller. That 1/8 is the smaller one, so I'm going to subtract 1/8 n from this side and 1/8 n, 1/8 n from this side. Those are going to go away. Okay, so that means the variable is going to end up on this side of the equal sign. So let's go ahead and move that 8 at the same time. Let's add 8 to both sides here. So those are going to go away. So here's what we've got. On this side we end up with, let's see, -3 plus 8. That's going to be a 5. Again, if you need to double check on your calculator, you could. And then we've got 3/8 minus 1/8. So 3/8 n minus 1/8 n. So 3/8 minus 1/8, that's going to be 2/8, which is going to be 1/4. Okay, but again, just to double check, let's make sure we don't mess anything up here. We're going to go ahead and put this in the calculator. So we're going to put in 3/8, and then we're going to subtract, do that alpha f1, bring up that fraction palette. So this is going to be 1/8. And again, it should give me the reduced answer here. So 2/8 simplifies to 1/4. So that means the coefficient is 1/4 on the n. And again, we get rid of a fraction in front of the variable by multiplying by its reciprocal. So we're going to multiply by 4 over 1. We're going to multiply by 4 over 1, which we kind of need to keep these as fractions on this side because those cross cancel, so we end up with 1n just like we want. But we don't really have to think of 4 over 1 as a fraction. If you wanted to write both of these as fractions, put them both over 1, that would be fine. If you wanted to think of this as just 4 times 5, that would be totally okay. I am going to keep those fractions there just so that the work is all there. But 4 times 5 would be 20. The 1 on the bottom we don't need to write, so that's the answer on that one. Good luck on the test. If you need to do this a couple times, that would be great. You've got this that you can watch. You've got a lot of resources. Don't be afraid to go back and take a look at your assignments and the notes for this unit. Really important that you do well on this test. Well worth your effort. It's going to make the rest of the year easier. And frankly, all the math that you do, it's going to make it easier. Good luck.